So today's panel discussion is about hyperscale evolution through the years. This is in part due to Hyve turning 10 this year, and we wanted to sort of mark that milestone. And to do that, we've gotten leaders from the pillars of hyperscale, namely compute, storage, and connectivity. So representing compute is Greg Ernst from Intel. Representing storage is Jeremy Werner from Micron. And connectivity is, of course, Broadcom's Jas Tremblay. And I'm Jay Shenoy. I'm the VP of Technology for Hyve. It's my pleasure to work with these people individually as well as their companies. And with that, can we request each of you to make some introductory comments, starting with introducing yourself? Greg first.
Hi, everyone, and thank you to our great partner Hyve for inviting Intel to be part of this. My name is Greg Ernst. I get the pleasure of leading our U.S. sales and marketing organization at Intel. We're working with all of with Hyve's customers and working every day with Hyve is a great partner.
Jeremy, would you like to go next?
Thanks, Jay. And also, great to be here with such esteemed colleagues like you all today. So I'm Jeremy Werner. I'm the general manager of the storage business unit at Micron. And basically that means everything NAND related for compute, cloud, etc. A little bit about Micron. Micron is the fourth largest semiconductor company in the world, the second largest in the US. Greg, you've got us on that. Jas, you've got a little work to do to catch up. And actually almost $25 billion in annual revenue. And you would find our products in just about everything that runs on electricity. So cloud computing, servers, storage, PCs, cell phones, automobiles, pretty much if it has electricity, it has a Micron chip in it. And, really so excited to be here. And, just the last thing I'll add is a lot of focus for us on solid state drives and our advanced DRAM into the cloud market, as well as our now burgeoning efforts on bridging the gap between fast storage and near memory with CXL. So thank you.
Jas?
Hi, Jay. Thanks for the invite and congratulations on the 10 years. It's been exciting to see Hyve grow throughout these years. So I'm Jas Tremblay. I'm with Broadcom, and I'm the general manager for the data center solutions groups, focus on connectivity within the data center, especially PCIe, storage, and Ethernet connectivity within server and storage appliances.
Very good. So let's go to our first round of questions on how we got to this point, and especially in the last 10 years, which coincides with the rise of hyperscale. Greg, starting from compute, since you've seen this firsthand, the hyperscalers today have a lot of media presence. In some cases, actually, they are the media. Starting from about 10 years ago, can you walk us through how hyperscale is sort of directing this whole compute industry in terms of technology and also market?
Yeah, absolutely. So, as you all know, Intel is a compute company. Increasingly, we will become a memory company. Our mission, our purpose is bringing compute to help every business create new products and services that enrich human lives. That's what all of my coworkers at Intel, what we wake up to do every single day. I'd say early on, hyperscalers became a dream partner of Intel's. They expanded the accessibility of compute, which is the resource that we create. They absolutely identified new products and services and brought them to market. And for us, they really accelerated the rate of those new products and services coming. They also operated at an incredibly large scale. So as I said, that their CSPs, the hyperscalers, are dream partner of Intel's. And the rate of acceleration has just continued over the last decade and really over the last 15 months as the world's been working through with COVID. Throughout this time, Hyve has been critical partner to the ecosystem for the last 10 years. I love, and we love, and your customers love Hyve's ability to create custom solutions. We love that you've gained the ability to operate at the scale that these markets need. So huge thanks to all the employees of Hyve for everything you've done. And then for us at Intel, our conversations with these hyperscalers, there's always an eye to the future, and we're always innovating with ourselves and with the ecosystem around. What do we do to further accelerate and always be mindful of scale? So we're looking at things constantly, like how do we overcome the limitations of power? How do we get greater scale? And that's a lot of our conversations every single day in and day out. And then the second thing, behind the scenes with CSPs, a lot of conversation with software. In my estimate, there's over 1 trillion lines of code that have been written and optimized for Intel. Our job in CSPs have been an awesome partner, as well as the open source community, is identifying those next trillion lines of code. And Hyve's going to be a critical part of that. So thank you for the 10 years, and already today we're talking about the next 10.
Here we are. Jeremy, question to you. So 10 years ago, right? Imagine or try to recall 10 years ago, when you said storage, the standard storage device was a hard drive. In the 10 years, like petabytes became exabytes and now are imminently becoming zettabytes. And yet, when you think of the storage device, you could almost say, or could you almost say that the general issue storage device is now an SSD? And how did that transition happen? And what role did hyperscalers have in that?
Yeah, so it's a great question. So I'll tackle it a couple pieces at a time. So is SSD the standard storage issue device? Well, it depends on how you look at it. In terms of units and in terms of dollars, and certainly in terms of IOPS or transactions to storage, SSD is the standard, hands down. But in terms of bits, HDDs still are king of the hill and probably will be for quite some time. How did we get here over the last 10 years? Well, really, it's interesting because Greg talked a little bit about scale, and that's where it started. So I think when we look at hyperscalers, we think of this monolith. But the reality is hyperscalers have evolved just like all of our businesses and just like technology. So where they started was really as a scale out applications, search, social media, e-commerce. Those are three of the big hyperscalers that we all think about all the time, right? And in those applications, let's take search, for example. How did search work? A query comes in, and maybe you're searching on the internet or you're searching in your social network, but a query comes in and literally gets chopped into like thousands of pieces and farmed out to thousands of servers and then reassembled. And the slowest server to return the results sets the latency for the user experience. So, SSD latency was critical in that kind of scale out application for them to adopt it. The other big application that you think about there is picture storage, putting your photos on Instagram, putting your videos on YouTube, movie storage. These are large files. They take up a lot of room. The interesting thing is usually you take a picture and you upload it, or you make a movie and you upload it. You're not rewriting it very often. But thousands of people, or maybe millions or billions if you're Baby Shark, are going to come and watch that video. So the read requirements are very high, but the write requirements are kind of low. And that drives a little bit different requirement, but still needs the performance of flash, but doesn't need all the endurance that something that you're rewriting frequently would require. Now, fast forward to where we are and where we're going, the other side of hyperscale, these giants, or most of them, some of them, took their knowledge of how to, build massive data centers, and then they put virtualization and they put containerization on top of that infrastructure, and they became the public cloud that we talk about all the time, right? It's the biggest industry that's emerged in the world probably in the last decade. And when you look at the needs of that market, it's a little bit different, and it's driven largely by CPU count. Because when people come in and they rent a computer in the cloud, oftentimes they're just renting one core and a little slice of DRAM, and a little slice of SSD and some hard drive storage. And what you end up with is that application, that virtualized or containerized application, because the CPU vendors like Intel are scaling core counts over time, as those CPUs scale, that's going to drive more performance requirements, more capacity requirements for SSDs, effectively in the same form factor. So what we see on the public cloud side is maybe not as latency sensitive, but just raw bandwidth and IOPS and capacity per drive just goes up astronomically. And that's where we're headed.
Thank you. That actually segues nicely into Jazz's world, bandwidth, latency. So Jazz, can you walk us through connectivity? And connectivity connects or covers a lot of ground. Can you walk us through what the major technologies are and where we are at the moment with each of those in the data center?
So I'll take one of the things that Jeremy said, user experience. If you look at the past decade, really the data center is a tool to enable new business models and new creativity from software developers and engineers all over the world that are coming up with new applications, new business model, new things they want to do, and they need a data center to deliver those capabilities. And the challenge is you can come up with your software developer with these new things you want to do, and if the infrastructure is not there to support it at scale, it won't work. And you're limited by dollars, by power is a big challenge, and so forth. And what we've seen over the past decade, I think one of the biggest trends is the amount of tools, component tools, silicon tools at the disposal of data center architects has proliferated. So before it was like a switch, a CPU, and some drives. Now, if you look at what goes into the data center, you've got multiple tiers and categories of storage media, storage drives with different protocols, different interfaces. You've got JBOF appliance, you've got hard drives are still there in huge scale. You've got storage arrays. So just from a storage perspective, you've got multiple tools at your disposal to build out a data center. In terms of accelerators, you've got FPGAs being deployed in data centers, multiple AI, ML custom chips, GPUs, all these categories of devices that weren't there before that now are there. And, memory tiers. So what we've seen over the past decade is more devices, and each of the devices have unique connectivity requirements from a protocol perspective, from a latency, from a bandwidth, and they're all unique. So that's kind of the first thing is more device, and a connectivity problem becomes much more complicated and challenging, both for data center architects and for equipment providers. And the second piece is the pace of innovation around connectivity is increased because of all those other devices, but also because just of the nature of the ecosystem. So I'll give you one example. PCIe is a core protocol that's key for interconnecting components inside servers, inside storage systems, inside GPU servers. You need PCIe. To go from PCIe Gen 2 to Gen 3, it took the industry about 8 years. Now, in about the same time frame, we're working collectively to go from Gen 4 to Gen 5 to Gen 6. And it's tough. I'm gonna tell you, I speak to customers all the day, either data center operators or equipment providers, such as some of the discussions we've had, Jay, and this pace of innovation is challenging. And in some cases, I think as an industry, we need, especially from a connectivity perspective, we need to drive a responsible pace of innovation that the ecosystem can actually absorb. So I think those are some key things. It's the amount of devices, and because of the amount of devices, and they all have their unique requirements, is you're seeing a proliferation of fabrics inside the data center. So the big one that we're looking as a unifying fabric is obviously Ethernet, and Ethernet's been the most successful connectivity protocol inside data centers. But then you've got other pockets of fabrics that are important. You've got PCIe fabric that are key, and there's a lot of innovation going on there. And you've got multiple storage fabrics ranging from SAS switches. If you're a customer and you need to deploy tens of thousands of hard drives, you need to have a fabric, and you're going to invest in a fabric optimized for that. And then you'll see around AI, ML, GPU accelerators, we're at an exciting times from a standard perspective. You've got new protocols coming out, and people asking themselves, where should I go? What direction should I invest in? So I think for networking, Ethernet is the clear winner and will continue to be, and we have a very healthy, broad ecosystem investing in it. Within platforms, specifically within servers, I think that PCIe will continue to be key. I think we're going to see some innovation around memory disaggregation, memory serialization. That's going to be a key focus area for the next decade, but that's a tough problem to go solve, but I think the industry is trying to tackle that. And you're going to see example for SAN aggregation, fiber channel fabrics, which are still growing and applicable to many data centers. And I think the big unknown is, what do we do as an industry to interconnect accelerators? And I think with the consortium driven by Intel on CXL, that cleaned up a lot of networking protocols that were kind of struggling along and put them in clearly what's going to happen with them. But it's still unclear what will happen in the AI ML interconnect space that today is really dominated by PCIe as a fabric.
Yep, or proprietary interconnects, right? In other cases,
exactly.
That's a very good summary of each of the three sort of pillars of the hyperscale data center. So let's look to the future, right? And let's start with Intel and Greg. So when we look at the future, the first question that does come to mind is, okay, so all of these transistors now, like billion transistors, is kind of become fairly like routine, unimaginable even a few years ago. But the question keeps coming around to Moore's law, right? So now we are at atomic scale. And so the question is, like, what is the future in terms of Moore's law? Can you give us some idea on what to expect? It's a hard question. It's a hard question, I know.
It's a hard question with a simple answer. It's alive, and it's what the engineers at Intel, and there's 80,000 of us, what we wake up and focus on every day. If you will, it's our progress report on how we're doing for the industry. For us, I'm excited by the future. We have this concept here at Intel now we call no transistor left behind. Where every transistor in the CPU and in the server plays a critical role, all with the goal of accelerating the price performance, the performance per watt, which hyperscalers need at this scale. So we're excited around the future and our strategy. First thing that we're doing to continue Moore's law is innovating at the transistor level. We've brought in new FinFET transistors, which will eventually come into servers. Today it's in the client side. Additionally, we brought in new packaging technologies so that we can add layers of transistors within a single package. So those are two things at that subatomic transistor level, in addition to the quest to continuously shrink the width of the gate of each individual transistor. So that's number one, Jay. And then number two for us is really a focus at being able to address the needs at hyperscalers. We're really at this point, and Jeremy mentioned this briefly, they're focused on their microservices that they bring to market with an eye at more bespoke custom solutions for every single individual microserver service. And our big play on that is what we're calling IDM 2.0, Integrated Device Manufacturer 2.0. Mm-hmm. We announced it on March 23rd. We're open for foundry business. We've put a lot of IP. We're going to put a lot of IP that's accessible to that library. One is x86 cores, but then we'll also allow other semiconductors IP, ARM cores, and other semiconductor manufacturers. So that, with the eye of the future, is very interesting for a lot of our hyperscaler partners. We're in deep conversations since March 23rd around, at each customer level, how do they access that IP and that set of services. So that's number two, which is going to help keep us as an industry on that Moore's law. And then the third, and Jazz mentioned this briefly, is this concept of heterogeneous compute, where CPUs plus series of accelerators can all be programmed for Intel by a single language, and that's one API. So that's C, C++, and the underlying libraries. And we welcome the industry to participate on that. Just like Jazz said, we're proud to lead the CXL consortium for the industry. We're proud. It serves a big function. Again, all with the concept of how do we as an industry continue progressing on that Moore's Law's continuum in the future. And it is, and it will be, Jay, done through different engineering techniques than the first 20, 30 years of Intel. The future, we will achieve it. We will use different techniques, but that's what's the beauty of engineers. When challenges are faced, they find new ways to solve the same problem.
Yep. So thanks, Greg. So Jeremy, for what does that kind of mean for storage, specifically NAND storage? NAND is, as you know, like this exotic charge trapping sort of mechanism on a floating gate, and Moore's law was supposed to hit NAND much sooner than logic, and in fact, NAND should have stopped developing 5 years ago if all of the pundits are correct, and yet nothing has stopped. Nothing has even slowed down. So how do you explain that?
So funny you say it should have stopped 5 years ago, because I'm going to go back not 1 decade but 2 decades. Fresh out of college, just joined my first memory company. First chip I ever work on, 16 megabit, 230 nanometer, single level cell flash. And at that time, memory will never scale below 45 nanometers, and 2-bit per cell MLC will never work. Okay, now let's fast forward a decade ago. At that time, we're working on 8 and 16 gigabit die, and MLC is about to be adopted into the data center. It's already pretty well proven into client PCs. Maybe it'll work in the data center. TLC will never work. And oh, by the way, 15 nanometer is the end of flash in a few years. 10 years later today, Micron, we just introduced and launched our 176 layer 3D flash, which just, completely broke the nanometer scale economics. We are shipping 4 bits per cell QLC into the data center. And you say, well, okay, what kind of compromises are made? We just talked recently about the number of hard drive bits that are still shipping. And obviously, 4-bit per cell is a way to get down that cost curve closer to HDD. Well, here's some stats. So AI ML applications, we measure 8 times faster image set conversion for ingest with TensorFlow than a hard drive. For content delivery, multi-user streaming, 225x speed up with QLC drives versus a hard drive. And financial data extracts, 450 times faster. So you can find more details about those benchmarks on our website, micron.com. But what I'm saying is, it's every 5 years. 5 years from now, guess what? We're dead. But I don't believe that. Call me an optimist.
Yep. Certainly the case. Jazz, last question in this round to you. So in Hyperscale, right? So one of the most popular sort of laptop stickers says my other computer's a data center, right?
Yes.
Which is a very, very strong connectivity assertion. More than so, as impressive as CPUs have been, as impressive as SSDs have been. When you say that your computer is a data center, it's a connectivity statement. How should we think about that?
So I think we need to think about it as the end-to-end infrastructure that connects the whole planet, from your home, from your car, from your mobile device, at work, and there's so many connectivity problems that needs to be solved, and it needs to stay balanced, because if you overinvest in one area and underinvest in the other, you're not getting the customer experience and so forth. So, you talked about Moore's Law and so forth. I think we're challenged there. I think we're at a different stage as a semiconductor industry than we were for the past 20 years. And it's important that we be cognizant of this. There's what we've done as an industry over the past 10, 20 years is built upon products. And the typical mindset in the technology space is let's add features, let's add things to it. And from a connectivity perspective, one of the quests is to provide a unified connectivity framework. And saying, hey, let me converge these things. So example, on the storage front, one of the things that we've done is says, hey, let's run SAS, SATA, and then NVMe on a single SerDes with a single connectivity infrastructure. So that's a small example of unification. But I think as an industry, we've been trained to generation over generation, add features, add capabilities, add complexity, add cost, add power. And we always justify ourselves by saying, hey, I've tripled the performance and the power only goes up 50%. Well, that's not working anymore. And what I foresee, because of the fundamental change in Moore's Law, is and something that we're adopting, and I'm personally adopting within Broadcom in my role, is a quest for simplification. And that means when you're an engineer and you're building products for the hyperscale data center, be more focused. Pick and choose what you want to do, pick and choose what you don't want to do, to have very focused, optimized products that deliver what they're supposed to do and not more, and do this at scale. And I think that's tough because you need to make decisions on what you're going to do and what you're not going to do. But the message I keep hearing from the hyperscalers is they've gotten to a certain scale that they want solutions just for them. And Hyve, you're part of this. And from a system perspective, it's challenging. From a semiconductor perspective, it's very difficult. But the reason they want that is because they cannot afford at scale to have bloated solutions that don't just do what they want. So I think what I'm forecasting for the next 6 years is more focus from a technology perspective, and only the focused technologies will be successful in hyperscale. And the innovation will come more from an architecture perspective. Mm-hmm. So the magic of shifting things from software to hardware. I think the biggest efficiency gain in data centers is optimizing the software profile, and we need to understand that as a semiconductor industry. Mm-hmm. So I think we've got a tough road ahead because we can't rely on Moore's Law as much. We need to be focused. We need to pick the problems we want to solve. And the hyperscalers are not very compromising in terms of, this is the job that I need to get done. Don't try to give me a solution that can do 3, 4, 5 things that I'm not going to be using.
Yep. Yeah, that does jive with our experience also. So thank you. These answers were quite enlightening and in some cases unexpected as well. So thank you for that. So now at this point, I think we can sort of wrap up with concluding remarks from each of you. Greg, if you want to lead us off in that.
Yeah, Jay, I just, I look forward to proving you wrong. Look forward to proving, Jazz wrong with some of his comments, right? But I would agree at the scale that the hyperscalers operate, the choosing the right features is critical. It is why we announced what we're calling IDM 2.0 with our foundry services to build those bespoke solutions and allowing the hyperscalers to pick and choose the IP blocks that they want, then we package, right? That is the vision, right? So, Jay, I looked forward to doing it with you and doing it with Hyve but the whole technology ecosystem, right? Jazz and Jeremy, we all wake up every day to help these hyperscalers because the services they provide to the world really does enrich human lives. And so we're going to do it as a technology ecosystem and community together. And I look forward to getting back at it tonight.
Yep. Jeremy, any last thoughts from you?
Sure. So, hyperscale, business scale, critical systems. I mean, we're just honestly at the beginning of this revolution. And things like AI and 5G, there's no doubt that whatever we can dream, we can do. And that's why I'm so happy to be here today with the valued partners from Broadcom, from Intel that we work with closely to ensure that we are interoperating successfully. And then with Hyve, that brings it all together as the system builder, as the integrator, as the vendor to actually deliver the systems to these data centers. It's really an honor to be here today with you, Jay. I'm really looking forward to the next 10 years of explosive growth and success and innovation together. So thank you all so much for inviting me to be here, and let's make it happen.
Thanks, Jeremy. Just last words from you.
So the hyperscalers are great customers, but there's a flip side to it that we often face, and they are fighting each other to have the greatest infrastructure and differentiate with cloud services, and they recognize that their infrastructure is a key competitive differentiator, and they're investing billions and billions of dollars in this and hiring some of the smartest people to plan their architectures and so forth. When with all that might and with all that scale, one of the things they try to do is commoditize the system providers, commoditize their suppliers. And I think one of the things I'm excited about in my role and what Broadcom is doing is we've architected the company to invest in specialized connectivity fabrics, whether it be Ethernet, whether it be PCIe, whether it be optical, whether it be fiber channel, whether it be storage. We've got separate divisions that invest in these areas, and we're not investing with a common plan of saying this is what the future of connectivity for the data center. We're investing for our customers, and what we see is that there's going to be more differentiation between one cloud data center and the others. And we think with all the innovation happening in connectivity, this is an area that we can help companies like Hyve and the system providers combat this desire to commoditize the supplier industry. So I think what you're going to be seeing is, if you compare 10 years ago to the next 10 years, you're going to see a lot more different architectures in the hyperscale data center. It's going to be specialized. And I think the way all these things are connected is going to be a core to how the architectures are successful or fail. And it's going to create a lot of opportunities for companies such as Hyve to differentiate by picking and choosing how they want to provide the connectivity of all these components. So I think it's going to be a challenging time because we're going to face with more and more problems to solve, but there's going to be place for more differentiation and the ability to win.
Yep.
And thank you for the invite, Jay.
Yep. Thank you. That was a good concluding set of comments. Thank you all esteemed panelists and partners. This is a great panel discussion, and I'm sure there'll be many questions that follow. Thank you.